All right, back at it again. Compound interest. Taking this a little bit further. The first few problems in this worksheet start off kind of boring, honestly, with just simple interest over and over until you create that understanding that compounding it works in the long run, saves us a lot of time. Did I mention I hope you're having a great day? Okay. $2,000 earned in 1 year at the rate of 4.2. You have your principal. You have your rate. You have your increment of time, which is just 1. Okay, so that's just a pretty simple one. Just plug in because you've got everything for your principal, your rate, and your time. That eventually will get you $84. Remember, for the rate, move that decimal point over once, twice, getting you 0.042 for your rate. So just plug that in here, plug in your principal, move on. How much interest would $2,000 earn compounded annually in 2 years at the rate of 4.2? Well, recall that now that we are shifting gears, we don't quite just have 2,000 in the bank. How much do we have? We actually have the 2,000 and the 84 from the previous year. So put that in, $2,084. And this is now over the increment of 0.042 for the rate. And this is now just one more year because, again, this is after 1 year, it's 2,084. If we take it another time, I'll share my calculator screen for this one. So this would be 2,084 times 0.042. And so this is saying that after, wait, no, hold on, that's not right. Well, what's this asking? One more time. Compounded, how much interest would it earn over 2 years at that rate? Well, we see that here, this is $87.53. So let's actually take note of that. And that's going to help us here because, again, this would just give us the amount for that second year. So 87 and 53. But again, that's not necessarily what's being asked here. It's how much for in 2 years for all of that interest. So if you take 84 and you add on that 87.3, that gets you approximately, get one here, add that one there, $171.30 ballparked for interest. Wait, am I missing an amount? Sorry, this is 53, right? Yeah, 53, my bad. Okay, something. It's 53, 53. Simple change, okay. How much interest would $2,000 earn with simple interest in 2 years at that rate? So if this was simple interest with 0.042, now over the span of 2 years, what do you think? Do you think that this is going to be more or less? Well, let's find out. Let's go to the calculator. We're doing 2,000, 0.042 times 2, 168. So slightly different. So that means that we don't just get the same amount, because this is definitely 168 when it's compounded in a simple fashion. Compare the two, explain why they differ. Why do you think they differ? What's really the difference between compounding and simple? Well, the compounded is definitely going to be more because it earns interest in the compounded case. So this up here is definitely greater than the 168 because if it's compounded, it uses how much you made in interest. and then just keeps taking that in and taking that in, and then compounding off of that, compounding off of that. So compound uses how much interest was made, or, you know, interest made. There you go. What else? Let's skip some of these. Deposits 1,000. I'll do this one. Margaret deposits 1,000. So we have a principal in a savings account that pays 5.4%, which is our rate, compounded semi-annually, which means that this happens twice in the year, balance after 1 year, where this is time. Okay. So we have our principal. We have 1 plus that. Our rate should be 0.054. Number of times this is happening is 2. And this is, again, out here, and this is over the span of 1 year. So really, and I'll show you the calculator on this. Since we're getting the balance, we do want to add on that 1 inside parentheses. If it was just asking for how much interest we get, we wouldn't do that. But all right, 0.054 over 2. Out here, 2 times 1, you can just simplify that to 2. Then let your calculator take care of the rest. So I'm doing just that. I'm doing 1,000 multiplying with 1 plus, I put a fraction here, so I use decimal or parentheses to make that happen. Divide that by 2. Close that out. Put an exponent of 2. Should be $1,054.73-ish cents. Okay. Does that sound good? Does that make sense? So let's write that on in. So we had $1,054.79. Sorry, 73 cents. It's rounded. Small change. This gives you the principal. This gives you the rate. If it's compounded quarterly, how many times do you think that's going to be compounded? Hopefully you're saying 4. And if it's over the span of 3 months, that's 3 months out of how many months total? Hopefully you're saying 12. So that's T. Remember, for your rate, you would use 0.028. You can take that further there. What else do we got? Deposits 6 G's. It's probably a principal. This would make 0.032 our rate. If it's compounded quarterly, n is going to be equal to 4. Balance after 1 year, where this is pretty much claiming t equals 1. All right, I'll show this one. We're asking for our balance, so I'm definitely going to give respect to that. Putting 1 in parentheses, 0.032 is up here. This is compounded quarterly, so we're dividing by 4. Out here, we'll have n again, and then just 1 for that 1 year. Let's see what this is. You'll notice that your calculator is going to be your best friend for these sections, so I think it's important to rely on that and have it on hand. It doesn't hurt. You still have it somewhere, right? You didn't leave it at your SATs. So I got 6 G's. I'm multiplying that with 1 plus, and again, I put fractions here because it's I have a fraction here, but I'm putting parentheses. But anything else? Yeah, up to that 4th power. So 6,194.32. Boom, there you go. Let me switch this back. There you go. And that was problem 9. Seems simple enough, right? I think where I see students trip up is they forget that compound interest has a specific type of equation to it, but don't let that throw you off. Let's see here. Interest, when $y earn in 1 day, it's a 1 day, that would just be 1 of 365 days. which would be our time, and at a rate 0.0375. If this was compounded daily, that would be 365 chances in the year. So that's N. Y dollars is there for our principal. And we're just finding the interest. Okay, so that's not too bad. I'm going to have Y out here and inside. I'm not going to add 1 because I just want interest. So if I was taking this further, I know that I need my rate. And I'm going to divide that with N, 365. This is going to happen N times T, which is pretty much just 1 time. This would be your interest. And so it's okay that Y is in there as a variable. They're trying to make you think that it doesn't matter about the numbers, that you should just kind of understand how it's going further. That's a really big takeaway. They're trying to make you think it doesn't matter about the numbers. And I'll do some down here too. It's fine. I got some time. This morning, Mrs. Rulin had a balance of B dollars in an account that pays 3.05%, so 0.0305 compounded weekly, which is going to say that happens 52 times in the year. This afternoon, she makes a withdrawal in the amount of W. Express her interest for the day algebraically. Okay. So let's see. We start with B in an account where we have that rate and we're expressing interest, okay? This afternoon, so before the end of the day. This is interesting. Okay. Interest for the day. Balance of B dollars pays 0.0305 compounded weekly. So I'll probably need 0.0305 over 52. And then the withdrawal is a big idea also, because this should happen, like we want to actually deduct that from our principal. And then this occurs 52 times, but this is just 1 day out of the 365. I'm going to go ahead and say that's it. Correct me if I'm wrong. Or maybe it's something slightly different. Maybe, I don't know. Do we need an exponent there? Let me think this one out. So we have the new balance, which is definitely B minus W. And it's compounded weekly. And we put that in 0.0305 times that 152. Oh, so this is just after 1 day. So actually don't think that we need this part here. So we actually can get rid of this. We don't need that exponent because this is just after 1 day. And we're giving respect to the number of days. And this is actually, this can just use simple interest, honestly, because we're not, yeah, so we can actually cut out a little bit here. So we don't necessarily need this, my bad. So that would work just fine. B minus W is there. You have it 0.0305 over 52. I hope that helps. If you have any questions, holler, let me know.